So when we're talking about today's lesson, we're going to focus mostly on mass number and on these things called isotopes. Does anyone remember from year 9 what an isotope is? Anyone have any ideas? It's where we change the number of protons, neutrons, or electrons. It's one of those three. Any idea? It's where we change the number of neutrons, okay? The neutral things, okay? So what we're going to do today, okay? We are going to explore this idea. Before we get there, let's just very quickly talk. All atoms of a particular element are always going to have the same numbers of protons and electrons. Okay? They always have the same number of protons and electrons. And this means that all atoms of a particular element can have different numbers of neutrons. So let's have a read through this passage together. Okay? I'm going to highlight some of the keywords along the way. The mass number of atoms and ions cannot be determined using the periodic table. Okay? If a sample of a particular element was analysed, so that's if we take a bit of an element, okay, the mass of the atoms would not all be identical. So I'm going to highlight that there. That is a key idea for us when we're talking about isotopes. That's like me saying if I grab a big spoonful of carbon and I weighed every single individual carbon, they would all weigh slightly differently. It's the same way that if I grabbed every single 32-year-old on the planet and I weighed every single 32-year-old, despite them all being the same age, would they all weigh slightly differently? Yeah, okay. And it's the same thing with our atoms and our elements here. Same thing, different weight. Okay. Now, this is because they have different numbers of neutrons. Okay. That is it. That's all of today's content done. Okay. All we're going to do now is practice it a little bit. Okay. Now, it doesn't change the identity of an element. So it means that carbon can weigh 12, or carbon could weigh 13, or carbon could weigh 14. Okay. Same element, just a different weight. Okay, so the mass on the periodic table, important thing for you to note, is the average of all of the atoms of that type. So one that I would like to point out to you right now is going to be, let's go with chlorine. So I want you to look for element number 17 on your periodic table. Okay, and when you find chlorine, what is the weight for chlorine? 35.5. Now, does it have half of a neutron and half of a proton? The answer is no. Again, this is an average. This is the average number of chlorine because we can have 35 or 37. Yeah.
Are there any tissues?
I'm not too sure. Maybe towards the back there. So, chlorine has two stable isotopes, okay? 75% have a mass of 35, the other 25% have a mass of 37. Okay, so overall, as you saw on your periodic tables, the average there is 35.5. So let's talk about chlorine first. Remind me, what number is chlorine on the periodic table? So put your finger on chlorine again, you would find it is number,
17.
and that number, that atomic number, means that is the number of protons, 17. Now in an atom, okay, how many electrons are there compared to the number of the protons? Is it the same or is it different? It's the same. That's our big rule up the top, right? All atoms of a particular element have the same number of protons and electrons. So we go down here, the number of electrons is 17. Now, for the number of neutrons, okay, we have this idea called the mass, and we subtract the atomic number, or the number of protons, okay? So, in this case here, the mass is the number after chlorine, and the atomic number is the same as the number of protons. So in this case, I'm going to end up writing 37, as 37 is my mass, and I'm going to subtract what number from it?
17.
Great. Subtract 17. And this is going to give me my answer, how many neutrons I have, which is going to be 20. Okay. So, our next example. It's still chlorine, it's just a different version of chlorine. So if it's still chlorine, how many protons is it going to have? 17. It's going to have the same number, so 17. How many electrons will it have? Yeah, 17. And here's the tricky bit, okay? In an isotope, the mass is slightly different. So what was our mass in this instance? Where do we get the mass from?
37 minus 17.
Very close. This time we're looking at our second example, so it's always the number after the word. So it's 35 this time, okay? And we go 35 minus what? 17. Awesome. And that's going to give us 18. So when we look at these two chlorines, what's the only difference between them? What is the only thing that is different? The number of neutrons. And so these are what we call isotopes. So here's what I'm going to get you to do now, okay? I'm going to set it up in the same way for you, okay? I want you to have a look at these 4 different elements. So the first thing for you to note, I'll highlight it here. The mass is this number here. This is the mass. It is how heavy it is. You are going to use your periodic table to firstly find the number of protons, and the number of protons is the same as the atomic number. Okay. What you're then going to do is we go mass, subtract, so take away the atomic number, and that gives us the number of neutrons. So let me highlight that there for you, and that there. I'm going to wander around. Let me know if you need a hand.